So here we have to determine the limiting value of the given function when x approaches 0. So we begin by doing a direct substitution for the value of x. So that will give us square root of 2 plus 0, which is simply 2. So minus square root of 2 divided by 0, which is equals to 0 over 0. So this is an indeterminate form. Now, in order to solve this limit, so we're going to use the rationalization method, because the numerator of this function involves square roots. So in the rationalization method, what we are going to do, so we take the function, which is square root of 2 plus x minus square root of 2 divided by x. Now what we are going to do, we are going to multiply the numerator by its conjugate. So its conjugate will be square root of 2 plus x. So the negative sign will get converted to a positive sign. So we multiply this conjugate term to both the numerator and the denominator. The reason why we have done it, so that we can apply the identity a minus b. So this is a, so this represents a and this represents b. So we have a minus b times a plus b. So this could be rewritten as a squared minus b squared. So let us do that. So we'll have a, which is square root of 2 plus x. So we have square root of 2 plus x whole square minus the square root of 2 whole square divided by x multiplied by square root of 2 plus x plus square root of 2. So this will be equals to limit x approaching 0. So square root of 2 plus x whole square will be simply 2 plus x minus 2 divided by x multiplied by the square root of 2 plus x plus square root of 2. So the 2 and negative 2 gets cancelled out in the denominator and the numerator, and that is going to leave us with limit x approaching 0. So we have x in the numerator divided by x multiplied by square root of 2 plus x plus square root of 2. So now we can factor out the x from both the numerator and the denominator, and that is going to leave us with 1 over square root of 2 plus x plus square root of 2. Now we do the final substitution. So we have 1 over square root of 2 plus 0 will be simply square root of 2. So we have square root of 2 plus square root of 2, so which will be equals to 1 over 2 root 2. So if we rationalize it, so that will be equals to root 2. So that will be equals to root 2 over 4. So this is the limiting value of the given function when x approaches 0. Let us do another problem. So here we need to determine the limiting value of the given function when x approaches 0. So first thing first, when we do a direct substitution for the value of x, we get the indeterminate form or 0 over 0. So we proceed like the previous question. So we are going to rationalize the denominator this time. So we have x divided by square root of a plus x minus the square root of a minus x. So we take the conjugate of the denominator, so that will be square root of a plus x plus, so the negative sign will become a positive sign, plus a minus x, and we multiplied it to the numerator as well. So we have square root of a plus x plus the square root of a minus x. So this will be equals to limit x approaching 0. So we have x multiplied to the square root of a plus x plus the square root of a minus x divided by, so now we have the standard form, which is a minus b times a plus b. So we are going to use the identity that this is equals to a squared. So that will be root of a plus x whole squared minus b squared. So b here will be square root of a minus x whole squared. So that will give us limit x approaching 0. We have x in the numerator times, so no change to the numerator, so that will be as the previous one. So we have square root of a minus x divided by a plus x. Square root of a plus x whole square will give us a plus x minus, so we have a minus x, the square root of a minus x whole square, so that will be a minus x. So we have limit x approaching 0, x multiplied by the square root of a plus x plus the square root of a minus x divided by, so we have a plus x minus a, so minus or minus x will become a positive x. So the a and a gets cancelled out, leaving with us with 2x in the denominator. So we have limit x approaching 0, x multiplied by the square root of a plus x plus the square root of a minus x divided by twice of x. So we can factor out x from both the numerator and the denominator, and then finally substituting for the value of x. So we have square root of a plus 0 plus the square root of a minus 0 divided by 2. So we have square root of a plus square root of a, which will be 2 times the square root of a divided by 2. So we can cancel out 2 and 2 from both the numerator and the denominator, and that will give us the limiting value of square root of a, and this is going to be the limiting value of the given function when x approaches 0. Let us do another problem. So here we have a function given by x squared minus 16 divided by the square root of x squared plus 9 minus 5. So we have to find this limiting value when x approaches 4. So let us begin by first substituting the value of x. So we have 4 squared, so that will be 16 minus 16 in the numerator divided by the square root of, so we have x squared, so that will be 16 plus 9 minus 5. So we have a 0 in the numerator, so that will be divided by, so 16 plus 9 is 25, so minus 5, so we have 0 divided by square root of 25 will be 5, so 5 minus 0 gives us a 0 in the denominator as well. So that means we are getting an indeterminate form. So we have to do some factorization, but before doing some factorization, what we are going to do is we have to get rid of the square root from the denominator. So that can be done by rationalizing it. So we consider the function x squared minus 16 divided by square root of x squared plus 9 minus 5. So we take the conjugate of the denominator, so that will be equals to square root of x squared plus 9 plus 5. So we multiply that to the numerator as well as the denominator. So we rewrite it in the numerator as well. Now that gives us limit x going to 4. So we have x squared minus 16 multiplied to the square root of x squared plus 9 plus the square, there's a mistake here, so this is not square root of 5, so this is simply 5. So this is a 5 here. So we have 5 divided by, now we can apply the identity, a minus b times a plus b is simply equals to a squared. So we have a square root of x squared plus 9 squared. So that will give us x squared plus 9 minus 5 squared. So that will be 25. Now we have limit x going to 4, x squared minus 16 times square root of x squared plus 9 plus 5 divided by x squared of, so 9 minus 25 is 16. So we see that there is a common factor x squared minus 9 present in both the numerator and the denominator. So we're going to cancel it out, and this is going to leave us with limit x approaching 4. So we have a square root of x squared plus 9 plus 5 divided by 1. Now we put the limiting value of 4. So we have 4 squared, which is 16 plus 9 plus 5. So 16 plus 9 is 25 plus 5. Square root of 25 is going to give us 5. So we have 5 plus 5, and that gives us a limiting value of 10 for the given function when x approaches 4. Let us do another problem.